Hey guys, so today we're talking about systems of quadratic and linear equations. If you remember, systems of linear equations when we graph them was just two or more equations for which we figure out whether they intersected or not. Today we're going to continue graphing two equations, a system of two equations where one of them is going to be a line and the other is going to be a parabola, like the ones that we learned how to graph last week. Okay, so if we look at our two equations that we have right here, our first one is y equals x squared plus 4x minus 5. Now, what type of shape am I going to get here? Am I going to get a straight line or am I going to get a U shape? Yes, if you said U shape, then you are correct. And why? Well, if I look at my biggest exponent that I have here, I have a 2. Okay, so therefore if my biggest exponent is a 2, then that means that the shape that I should be getting should be either a U shape like this or a U shape like that. Okay, so what I'm going to do right now is I'm going to go ahead and go to my calculator. I'm going to go to y equals, and in y equals, I'm going to go ahead and put the equation x squared plus 4x minus 5. Okay, once I do that, I'm going to go to second graph so that I can get a table that looks something similar to what I have right here. Okay, so now that I have the table for the first equation, and I'm only going to graph one equation at a time, please do not try to graph two equations at a time by putting them both in y1 and y2 because it's going to be a lot of numbers and it's going to become a little bit overwhelming. So now that I've put my first equation in my y equals in my calculator and I've gotten the table, I'm going to go ahead and graph it. But I know if I'm graphing a U-shaped graph, if I'm graphing a parabola, then the first point that I need to look for is my vertex. So as I scroll up and down through my calculator, I'm looking to see where is the turning point of this graph? Where do the numbers start to repeat again? Right? So in my graph, in my y values, I went from -5 to -8 to -9 and back to -8 and -5. So I see that at this point right here, I'm starting to turn back around. So that is my turning point. That is my vertex. The other way that you can look at this is if you look at your y values, right? -9 is going to be the only one that doesn't have a partner. For example, -5 is partnered with that -5. -8 is partnered with that -8. But that -9 is lonely. Okay, your vertex is always lonely. It's always by itself and never has a partner in the y value, whereas all the other points do. So I'm going to go ahead and graph my vertex. I'm going to graph -2, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. And then I'm going to graph every other point that I can fit in my graph. I know that my table right here only shows me 5 points. That's because it's a screenshot, right? So I can't scroll up and down the screenshot, but I know that if I scroll up and down the calculator, that there are a lot more points that I can plot on my graph, and I'm gonna go ahead and graph all of them. I'm not just gonna plot 5 points just because those are the only 5 points that Ms. Trinidad is showing me. I'm plotting every single point that I can fit in my graph. So I'm gonna start with what I have on my table right here, and then I'm gonna go ahead and add anything else that fits. So I have -3, -8. I have -4, -5. I have -5, 0. -5, 0. And I have -6, 7. -6, 7 right here. Okay, and then I'm going to go ahead and graph everything else on the other side of my vertex. So I have -1, -8. I have 0, -5. I have 1, 0. And I have 2, 7 over here. Okay, now if you scroll up and down your calculator, you'll see that the other points are too big. They don't fit. So now I have all the points that I fit, and now I'm just gonna make them a little thicker, and I'm gonna go ahead and connect them. I'm gonna try to be as careful as I can when I connect them, because I want to make sure that my graph looks like a U. It should not look like any other shape but a U. Okay, and also don't forget your arrows. Okay, this is not a V, this is a U. It has a turning point. It means it should turn at the vertex. Okay, it's not a P, it's not a V, it's a U. So one thing that I'm going to ask you guys to get into the habit of doing is that anytime you are graphing more than one thing on your coordinate plane, you want to make sure you label everything that you graph. So I'm going to label this graph as y equals x squared plus 4x minus 5. And when I say label, I just mean write down somewhere next to it what equation is it that you've just graphed. It also helps you keep track of your work. So now that I've graphed the first line, I'm going to go ahead and graph the first equation. I'm going to go ahead and graph the second equation that I have here, which is y equals x minus 1. Now if you can tell here, this is in the form of y equals mx plus b. This is not a quadratic equation, okay? This is a linear equation, so I should get a line either going like this or a line either going like that. Okay, this is not going to be a curve. The biggest exponent here is a 1. This is a linear function, a linear equation. So I go ahead, I'm going to go to y equals. I'm going to erase this that I had originally in there. And now I'm going to go ahead and put in my new equation over here in y equals. And now, once I put that in y equals, I'm going to go to the table and I'm going to go ahead and start plotting my points. Since this is a straight line, I can literally start anywhere on my graph, as long as I graph every single point that fits into your coordinate plane. So I'm just going to start with what I have here, -2, -3, -1, -2, 1, 0. Okay. And I figured out the pattern, so I know that I can just go ahead and continue the pattern both ways. If you're not comfortable with doing it that way, then just plot all the points that fit according to your table. And now I can go ahead and connect my points. Oops. Connect my points. Make sure you're using a straight edge if you don't have a ruler. And I'm gonna go ahead and label it. This is y equals x minus 1. Okay, so now that I've graphed both my parabola and I've graphed my straight line, most of your graphs are going to look something like this or something similar. Now I want to look for where these lines intersect. Where do these lines meet with one another? Where do they cross each other? And if you're looking at this graph, there should be something that points out to you. How many times do these two lines meet with each other? How many times do these two lines cross with each other? If you said 2, you're correct. There's actually 2 points where these two lines meet with one another. There's a point right here, and there's another point right over here. Okay, so the solution to the system of equations is actually not one. There are 2 solutions to the system of equations. Okay, and they are the point. This green point is the point 1, 0, and this other point, the orange point, which is -4, -5. Okay? You have your green point, and you have that orange point over here, which is the 2 points where these two lines intersect. So those are your solutions. So make sure when you're graphing today, just because you see one point, you're like, oh, that's it, that's my solution, I'm done. No, there are going to be cases where your lines are and your line and your parabola are going to meet more than one time. So you want to make sure you are graphing every single point that fits into your coordinate plane so that you can tell exactly where those two lines intersect. Now, how do I prove that I've done this correctly? How do I prove that these are actually solutions to my system of equations? if you said plug in, that was correct. Okay, you want to make sure you want to check by taking these points, plugging them into your equation, and seeing that it works for both of them. So I'm going to show you here. Here's my check. Okay, first I'm going to check for my parabola. I have y equals x squared plus 4x minus 5. So first I'm going to check the first point. My x here is 1 and my y here is 0. So I have 0 equals, in parentheses, I'm going to go ahead and put whatever the x value is, which in this case is a 1. Okay, so I have 1 squared plus 4 times 1 minus 5. And when I put this side into the calculator, you will see that it actually gives me 0, so it works. But I have to check that both of these actually work as well. So I'm going to check the other point. I'm going to check this orange point now where x is -4 and y is -5. So I have -5 equals, and again, anywhere I see an x, I know I'm going to plug in there. So I'm just going to put a parentheses. Okay, and I'm going to substitute in that x value. So I have -4 squared plus 4 times -4. And again, if you put this into the calculator, you will see that it will also give you -5. So now you want to go ahead and check that it also works for the other equation, because if you remember when we did linear systems, it has to work for both equations that you are graphing. So I'm going to go ahead and erase this on my paper, but because I don't have enough space, but you don't have to erase it on yours. So now I'm going to check for the second equation. So I have y equals x minus 1, and again I'm just going to substitute in my x and my y and check that the left side equals the right hand side. So for my first point, the one that I circled in green, I have 0, which is y, equals, I'm going to plug in something for x, so I need my parentheses, -1. And the x value here is 1. And of course, 0 is equal to 0, so you know that that point works. Now I'm going to go ahead and check for the orange point, the one that we circled in orange. So I have -5. I have -5 equals, I'm plugging something in parentheses again, -1. And in the orange point, x is equal to -4. And if you put this in the calculator, you'll see that it also gives you -5. So that point works as well. So we just proved that the 2 points that we circled as our solution are actual solutions to our system of equations, as it satisfies both of them. Okay, now the other thing that you can also do to double check your work, or if it's just a multiple choice, question is that you can actually check in your calculator for where the intersection actually lies. If I go to my calculator and I go to y equals, I can put both of my equations in y1 and y2, as you can see right here. Okay, you're not going to do that when you're graphing, because again, you only want to graph one at a time. But if you're checking just for the intersection, maybe it's a multiple choice question, or maybe you're just double checking your work, you can put both of them together. You can put one in y1 and the other one in y2, and then you want to go to your table. So on your table, you want to check where is y1 equal to y2. Where are the two values the same? And if you scroll up and down your table, you can tell that at 1 you have 0 and 0 the same, and you can also tell that at -4 you have -5 and -5 for y1 and y2 as well. So since y1 and y2 is the same here, that means that one of the intersection points is -4, because this is your x value, and the y value is -5. Okay, and then here your x value is 1 and your y value is 0, which is the same thing that we got when we graphed our equation. So if you have a multiple choice where you're not required to graph, you can use this to answer some of those questions. However, if the question is asking you to graph, please make sure that you are graphing those lines and graphing all of the points that fit.